Welcome to Train Signal. You're watching a lesson on TCP/IP ports and protocols. Now, the first thing that we need to talk about before we get into the actual protocols and the ports that they use is I need to talk to you about something called TCP versus UDP. This again, and I know I talked about this a bit in the last lesson, this is kind of a subset of everything there is to know when it comes to IP networking. Okay, so TCP/IP is actually made up of a 4-layer protocol suite, and there's one layer called the transport layer actually that will have two different protocols that are used. One is called TCP and one is called UDP, and you need to understand the difference between TCP and UDP, because as we get into the various protocols and the various ports that those protocols use, well, you'll see that some of them use TCP and some use UDP, so we need to understand this first. So, first of all, TCP stands for the Transmission Control Protocol, whereas UDP stands for User Datagram Protocol. I'm not overly concerned with you remembering those words. What I need you to understand is what they mean. TCP is a one-to-one type of transmission where you have one computer communicating directly with another computer. It's what's known as connection-oriented, and I'll explain what that means in just a moment. And because it's connection-oriented, it's considered to provide reliable communication. Whereas UDP is known as connectionless and therefore is unreliable. Now I'm going to explain the details of how this connection-oriented thing works, but let me just kind of give you the high-level generic side of it, which is it means that the two computers, right, it's a one-to-one relationship, they establish a connection so they can have reliable communication, whereas connectionless means you just kind of send it and hope it gets there. You'll also notice that I don't have it listed as one-to-one. UDP is very often used in what's known as either multicast or broadcast communications, where you have one transmitter and many recipients. Thus the reason that you don't have an actual connection, you just put it out there and hope that it's received. So what does make TCP connection-oriented? Well, like I mentioned a moment ago, it means that a connection is first established, and this is done using something called the three-way handshake. And the three-way handshake works like this. The computer that is going to send or initiate communications with another computer will start off by actually transmitting out and saying to that other computer, "Hi, I would like to talk," right? I want to communicate with you. Here is the information that you need to know about me in order for us to have this communication. Part 2 of the three-way handshake is the other computer receiving that information and replying back, "Thank you. I got your information. Now here is the information you will need to know about me in order for us to have communication." And then the third part of this three-way handshake is the initial computer saying back to that other computer, "Okay, I got your information. So basically now that you have my information, I have yours. Let's begin talking." Okay, and this takes place before any actual transmissions take place. In other words, each computer needs to go ahead and share its information with the other so that it knows exactly how to communicate and communicate effectively. And that is what makes it connection-oriented. Now, another way of realizing that it is reliable is TCP also uses a send and acknowledge type system. Once the three-way handshake is done and we're actually communicating data, I will send you data and then you will reply back an acknowledgement saying, "Got it." I send you data, you say, "Got it." You send me data, I send you, "Got it." Okay, it's kind of like sending something certified mail. I put it in the mail, I send it certified. When you receive it, you sign for it, I get an acknowledgement back to me from the post office saying this person did indeed get the communication and they signed for it and here's the proof. Whereas UDP, which is connectionless, is like just using traditional first-class mail. You stick it in the mailbox, you send it off, and you hope that they get it. There's no acknowledgement. Okay, and again, the reason why is because UDP is typically used more with a multicast or a broadcast type environment. One way of thinking about it is if you've ever seen like streaming media, streaming video or audio, like you go to a website and you're seeing like go to a news website and you see their television broadcast, their news broadcast streaming across the internet. That's what's called a multicast, and it uses UDP. They're going to stream out that video broadcast, but they're not going to confirm with every single person who's subscribing to it and say, did you get it? Did you get it? Did you get it? For every single packet of information. They're just going to put it out there and hope you do. And that's why sometimes the broadcast may lock up, right? Because your internet gets weak or whatever. No big deal. You might miss a few seconds of something somebody said, but then it just continues once it picks back up again. All right, so that's TCP versus UDP. Now that we have that, let's talk about the specific individual protocols and the ports that they use. And by the way, just to kind of give you a real quick definition of what we mean by protocols and ports. A protocol is a set of rules and procedures for communication. Okay? It's just a definition of the way certain types of communication are going to take place. And the port, there's a lot of different ways that I've seen this explained. It has a lot to do with firewalls, in the sense that if you want to allow or block certain transmissions, you can do it based upon the port that it's being communicated on. And when you take a protocol on a port and you bring it all together, you get something called a socket. But again, getting way out of context here, trying to throw a little bit of something at you so that you can grasp hold of what we're about to talk about. So the first protocol I want to talk to you about is something called FTP, the File Transfer Protocol. You'll never guess what this protocol is used for. Hey, it's used for the transferring of files or data from one system to another. Now, there's another version of FTP. Matter of fact, there's a few different secure versions out there, but there is one called SSH File Transfer Protocol, or sometimes just simply known as Secure File Transfer Protocol, or SFTP, which is where it gives you a more reliable data stream, a more secure data stream. So if you ever see that, that's what they're referring to. Now, FTP uses TCP port 21 for control information and TCP port 20 for the actual data transport. So the main thing I want you to remember is FTP, File Transfer Protocol. It's used to transfer files from one system to another, and it uses ports 20 and 21. If you're only asked about one port, the most common port that people will remember FTP by is actually port 21. Telnet. Telnet is a terminal emulation protocol that allows remote access to a system. It's actually an older, antiquated, terminal-based remote access system. Telnet is also sometimes referred to as software, which can be used by a client to remotely connect and configure various operating systems or networking devices. Again, older, antiquated, not used a whole lot other than for maybe some basic diagnostics. Keep in mind, if you're quizzed on this, Telnet uses TCP port 23. And by the way, if you haven't gotten the idea already, this is what the rest of this lesson is going to be all about. A lot of, I hate to say it, but memorization. I mean, it might be a little bit easy to actually not just memorize, but actually learn what the protocols mean and what they do. But the port numbers are just a matter of memorizing. And I wish I had something better to throw at you, but I don't. It really is a matter of memorizing. So if you are taking the certification exam, you have to remember these port numbers. So SMTP stands for the Simple Mail Transfer Protocol, and it's used for sending email to and between email servers. And SMTP uses TCP port 25. Now, if we're going to talk about mail, okay, this is the actual sending of mail, but then we have a couple other protocols here, POP3 and IMAP4, and these are used to retrieve email. Okay, so this is more for a client to retrieve email off of a server. POP3 is a version which you'll notice here it says can only be used for the inbox folder, and it uses TCP port 110, whereas IMAP4 can also use various messaging folders, not just the inbox. And you also don't have a local repository. You still keep the email out on the server, but with IMAP4 you use TCP port 143. Now, if you've ever set up an email client like Outlook to communicate with your favorite email server that you use, right? Whether it be with your maybe your cable company or whoever. When you configured Outlook to work with them, you may actually recognize ports 110, 143, and then going back to SMTP, port 25. You also may be familiar with the SSL version of those ports. SMTP, I believe, is 587. POP3 is 995. And this is where you're going to really challenge me. IMAP4, don't hold me to it. I think it's 993. You don't actually have to know those. Okay, I'm kind of throwing them out there as trivial information. Yes, you may need to know them in certain scenarios out in the real world, but you can always go look it up. Like if I had to know right now, I could look it up. For the A+ exam, they're not going to hit you that heavy with these ports. This is not a networking exam, but they will hit you with the occasional networking question. And so they're not worried about the secure ports, just the basic ports. SMTP is 25, POP3 is 110, and IMAP4 is 143. DNS. I talked about DNS in a different lesson where I talked about it being a name server so that we can be stupid humans and we can look things up via name and then it will convert it to IP addresses. But I will tell you that DNS servers, the communication, they use TCP port 53 for something called zone transfers, where they actually transfer information between the servers, and UDP port 53 for lookups, like a client actually trying to look up the IP address of a certain name. The main thing I want you to remember is port 53. You don't need to be too hung up on which one's TCP and which one's UDP as far as this one goes. Next we have HTTP, which is the Hypertext Transfer Protocol. Bottom line is, short version, HTTP, it's for browsing the web, right? Browsing the World Wide Web, the internet. What do I want you to remember about HTTP besides it being obvious that you use it in a web browser, right? Every time you go to google.com, go to CompTIA.org, you always start off with an address that says HTTP:// then you get the name. All right, so we know that it's for web browsing, but it uses port 80 by default. Now, besides HTTP, we also have HTTPS, which is basically the same protocol, but over SSL, Secure Sockets Layer, which means like if you're going to be giving credit card information, you want to have it secure. And this is going to use port 443 by default. Please remember those. HTTP is port 80, HTTPS is port 443. As a matter of fact, there's 6 ports that I'm going to tell you that you probably, if you can remember just these 6, you'll probably get every question right on an A+ exam. Not that they won't ask you about any others, but if you can remember these 6, you can probably deduce your way to the right answer, even if not, if for nothing else out of elimination. Like if they ask you about something else, they'll have these numbers in the choices. So the 6 I want you to remember, I've already mentioned them all. FTP being port 21, SMTP port 25, POP3 being 110, IMAP being 143, HTTP being port 80, and HTTPS being port 443. Those are the 6 most commonly used ports. We have something here called RDP, which stands for the Remote Desktop Protocol, which is something used by Microsoft, which allows you to basically sit at one computer and remotely look at another computer. It uses TCP port 3389. We have DHCP, which we talked about in a different lesson. It has to do with the dynamic handing out of IP addresses. DHCP servers will communicate using UDP port 67 and 68. This is actually significant if you ever have clients that are on one network and DHCP servers that they need to talk with on another network, because all DHCP communication is broadcast based, okay, meaning it's UDP based. And broadcasts, although I'm getting ahead of myself, it's a whole different lesson. They don't travel through routers. They don't travel from one network to another. So there's special setup circumstances that you can put into place to allow clients on one network to actually travel through a router to broadcast out to a DHCP server on another network. LDAP stands for the Lightweight Directory Access Protocol, and it's an application protocol used for accessing and maintaining distributed directory information services. In other words, it works with directory services, or in the case of Microsoft World, it works with Active Directory. LDAP communication primarily, and I'm going to say primarily because we have something called SNMP, which stands for the Simple Network Management Protocol. And you'll never guess, it's used for network management. The idea is it has devices out on a network acting as agents, collecting information, and then passing that information along to SNMP managers. And this communication, and by the way, the managers will then analyze the information, and you can manage your network from there. But basically, it uses UDP port 161. That is a very trivial piece of information, by the way. If you would have asked me 10 seconds ago, before I put this slide up, what port SNMP uses, I couldn't have told you. Okay, I looked that up, threw that in there. So I'd rather throw a little extra piece of trivial information in there than not share with you at all. But you shouldn't have to know that. SMB, or Server Message Block, is a network file sharing protocol that allows applications on a computer to read and write files and to request services from server programs in a computer network. So a lot of your basic back and forth communication between clients and servers. CIFS, Common Internet File System, is a standard way that computer users share files across corporate intranets and the internet. An enhanced version of Microsoft's Open Cross-Platform SMB protocol, CIFS, again, many consider them to be the same thing here. It's a native file sharing protocol in Windows. Here's the main thing I'm going to tell you about SMB and CIFS. SMB, was designed back in the day of NetBIOS and NetBEUI environments. Those are terms you're not familiar with, and you don't really need to be familiar with. What I can tell you is this goes back like to the 90s, and Microsoft insisted that these were going to be the protocols of the future, with only one small problem. They're not usable on the internet. Microsoft had no idea that the internet was about to take off the way it did, and that it was going to truly be the standard of networking. So even though NetBIOS and NetBEUI are pretty much dead, they're not. The SMB aspect of them are still out there, and it's used by different network monitoring tools and stuff to analyze your network. SSH stands for Secure Shell, and it can be used to provide similar functionality as Telnet, but in a secure way. Okay, so Telnet is considered to be insecure because it sends a very basic username and password. And so really you shouldn't ever be using Telnet. I already told you it was old and antiquated. You should be using SSH, and it employs encryption through certificates and authenticates the server to the client, all kinds of fun stuff, and it uses TCP port 22. And that, my friend, takes us to the end of this, quite frankly, boring. I mean, if I'm being real, I'm impressed if you're still listening and you're still paying attention, because basically I probably could have put a chart up on the screen and just listed a bunch of protocols and gave you a bunch of ports, and you could have memorized them for the test. I wanted to give you a little bit more than that, try to talk to you a little bit about what each protocol really did, maybe help you to try to remember them. But really what it comes down to for the A+ exam is a lot of memorization, and I apologize for that. But that does bring us to the end of this lesson. I thank you for watching, and I will see you, or at least I hope I do, in the next lesson.